Hello, and welcome to another video of tutoring with Leah Cremona. Today, I'm going to talk about finding the chemical formula of a compound from its written name. So one type of compound that we can find the chemical formula for is an ionic compound. And for ionic compounds, we want to pay attention to the charges of the elements, because these, as you remember, ionic compounds are made up of a metal and a nonmetal. And usually, the metal will be the element with a positive charge, and the nonmetal will be the one with a negative charge. And the values of those charges, positive 1, 2, 3, whatever it is, or negative 1, 2, 3, and so on, we need to know what those values are in order to write the correct chemical formula. The other type of compound is a covalent compound. And for these compounds, you want to pay attention to the prefixes. These prefixes will tell you the number of atoms for those elements. Okay? So remember from the other video, from finding the name of a chemical formula, the prefixes can be mono, di, tri, tetra, penta, hexa, hepta, octa, nona, or deca, each indicating a certain number, and those numbers will tell you the number of atoms for that element. And remember that covalent compounds are made up of two nonmetals. In this case, also, for covalent compounds, you do not need to pay attention to the charge because there is really nothing to worry about. For covalent compounds, you also do not need to worry about the charge. The charge only needs to be taken into account for ionic compounds, not covalent compounds. So we're going to go over some examples so that you can see this put into practice. So one example. So we want to find the chemical formula for cesium sulfide. Now, I have mentioned it in another video that ionic compounds can also be made up of a polyatomic ion in a nonmetal, or a polyatomic ion and a metal. So in place of either of these, there might be a polyatomic ion. And you would know that by knowing the formula for the polyatomic ions. So in this case, first we want to identify each of these parts and what symbols they represent according to the periodic table. So as we see here, cesium, right here, is represented by the chemical symbol Cs. So we know we have Cs for cesium. Then for sulfate, we would know from knowing our polyatomic ions that this is a polyatomic ion and that it is represented by SO4, and the charge for sulfate for a sulfate ion is -2. Also, from looking at the periodic table, we can see that cesium, because it is in group 1 of the table, cesium has a +1 charge. So we can also put that the cesium ion, has a +1 charge. The next step for this example is that because it is an ionic compound and we are dealing with charges, we need to find the least common multiple between the charges. So between 1 and 2. So the least common multiple is 2, meaning that 2 is evenly divisible by 1 and also by 2. So the next step is to put these two parts together, so we have one element and a polyatomic ion together, so that the compound has a 0 charge at the end, so that the compound is neutral. Because right now, if we put one of each together, this compound would have a negative charge, because we are adding +1, with a -2. And we know that 1 minus 2 is -1. But, as I said before, we want the result to be 0. And we know that we have a -2 involved. Remember I said that 2 is going to be a common multiple. And here we know that if we add 2 to -2, we'll get 0. So this is the charge of sulfate ion, okay, because it has a -2 charge. And this is the total charge from cesium. Now remember that each cesium is only +1. So we need 2 cesiums to get a +2 charge. So the end result is that we have 2 cesiums and 1 sulfate ion. And this would be the chemical formula for cesium sulfate. So once again, just to clarify, we indicate the number of atoms for a certain element or polyatomic ion by adding a subscript at the bottom right corner. And in this case, we needed 2 cesiums because in order for the compound to have a total charge of 0, and knowing that we have a -2 charge coming from sulfate, we needed 2 +1s to cancel out the -2. Alright, let's do another example. So find the chemical formula for potassium chloride. So first, you have to identify which type of compound this is. Is it ionic or is it covalent? Now, we know that there are 2 parts, potassium and chloride. So we're going to try to find those symbols on the periodic table. So for potassium, potassium is represented by the symbol K. So we know we have K We also know that chloride is here and is represented by Cl. Now, we identify which types of elements are potassium and chlorine. Are they two nonmetals, or are they a metal and a nonmetal? So we know that the metals are here, right? And we know that potassium is going to be a metal, so we have one metal, and we know that chlorine is a nonmetal. A metal and a nonmetal make an ionic compound, meaning that we have to pay attention to the charges. So, for reference, potassium has a positive 1 charge, and chlorine has a negative 1 charge. Now we need the end result, the end compound, right, to have a neutral charge, so a charge of 0. In order to do that, we know that we have one positive 1 here. We also know we have a negative 1 here. So 1 minus 1 is 0. So we know that simply the end result will be KCl. This will be the answer for potassium chloride. So we did not need to add any subscripts because we had nothing to cancel out. If you put a positive 1 with a negative 1 together, the charges will cancel out, and therefore we do not need any other subscripts in order to cancel out or to make our compound equal 0 with a charge of 0. And therefore we don't need any subscripts to cancel out any numbers to have a neutral compound. Now for an example of a covalent compound, find the chemical formula for triphosphorus pentanitrate. Now covalent compounds, remember, you have to pay attention to the prefixes. So the prefixes here are penta and tri. Now we know that tri here indicates 3 and penta indicates 5. So just for reference, I'll put them here, the prefixes. Mono is for 1, di is for 2, tri is for 3, tetra is for 4, penta is for 5, hexa is for 6, hepta is for 7, octa is for 8, nona is for 9, and deca is for 10. Alright, so once we have identified what our prefixes mean, what number they indicate, we need to look for the symbols of phosphorus and nitride. Now from nitride, you know that it would be nitrogen here. This is just the ion name. So phosphorus, we have two nonmetals, so we know that we'll look at the right of the periodic table, and we can see phosphorus is represented by a P. So we have P, and nitrogen is represented by N. So nitride indicates that we have a nitrogen. you can see that the ending "ide" is part of naming a chemical formula. Now, once we have identified what the prefixes mean and what the symbols are, we can put it all together. The numbers will be subscripts for the respective elements. So the chemical formula for triphosphorus pentanitride would be, so there's the phosphorus, and we know that we have 3 phosphoruses from our prefix, and that 3 is a subscript for the phosphorus. The next is a nitrogen, and we know that we have 5 of them. So the 5 here will go as a subscript. So this is the chemical formula for triphosphorus pentanitride. The prefixes indicate numbers, which we put as subscripts, and from the symbols from the periodic table, we write the chemical formula. So example 4, write the chemical formula for xenon tetrafluoride. So from xenon, we can see that we have the symbol Xe. And then here, we see that we have a prefix, tetra, and from here we know that it indicates 4. And fluoride is indicated by F for fluorine. So now we know that xenon and fluorine are 2 nonmetals, which tells us we have a covalent compound. And for covalent compounds, all we need to do is to write the element symbols and the prefixes as subscripts that indicate the number of that element. So here, the chemical formula would be xenon. We have the fluoride part. And we know that we have 4 fluorine atoms. So the 4 is represented by the subscript for the prefix is represented by a subscript of 4 only for fluorine. And this would be the chemical formula for xenon tetrafluoride. Alright, so the next example is to find the chemical formula for nickel-3 nitrate. Alright, so first we look at the periodic table to see that nickel here is represented by Ni, and nitrate is a polyatomic ion. So nitrate is NO3 -1. So it's made up of a nitrogen atom and 3 oxygen atoms, and the polyatomic ion has a -1 charge. We also know from the Roman numeral 3 that nickel has a positive 3 charge. So clearly, this is an ionic compound. We are dealing with a metal and a polyatomic ion. And as you can see, the polyatomic ion is made up of nonmetals. So basically we have metal and nonmetal, which makes it an ionic compound. Now for these, as in previous examples, the entire compound at the end must equal 0. So 3 and negative 1. So here we have to find the least common multiple between 3 and 1, and we know that it will be 3, meaning that 3 can be divided equally for 3 and 1. So we know that in the end, we have to have a 0 charge. Now right now, if we combine positive 3 and negative 1, we'll come out with 2, which is not 0. So we need to find a way to make this true. So what number goes here? What number, 3 minus what number will give 0? So we know that's 3. So that means that we need 3 nitrates with the positive 3 charged nickel to have a neutral compound. So in the end, the chemical formula for nickel 3 nitrate is Ni, parentheses, so here, this part, the part into parentheses, is the polyatomic ion, and we wrote the parentheses so that the 3 here, the subscript 3, can apply to everything in parentheses. Because if we wrote it without parentheses, right, it would be a little bit confusing with the 2 3's here. So in this way, with parentheses, we make it clear that this 3 applies to 3 nitrates. Okay, it applies to N and O, telling us that we have 3 nitrates. So this is the end result, our chemical formula for nickel 3 nitrate. We have 1 nickel and 3 nitrates. And just to check our work, we know that nickel has a positive 3 charge, and we know that each nitrate has a negative 1 charge. However, multiplied by 3, we know that negative 1 times 3 is negative 3, and we know that positive 3 minus 3 is 0, which is what we want. Okay, so this would be the solution for this. So the next example is to find the chemical formula for calcium sulfide. So once again, we look at the periodic table to see what symbols correspond with these two names. We see that calcium here is represented by Ca, and that sulfur is represented by S. Now looking here, we see that calcium is a metal and sulfur is a nonmetal. So we have an ionic compound, which means we have to pay attention to the charges. So calcium, because it is in group 2, has a positive 2 charge, and sulfide here has a negative 2 charge. Now we want the entire compound to have a 0 charge. So right now, if we put one of each together, we have a positive 2 and a negative 2, which is 0, which is what we want. So we know that we only need one of each. So 1 calcium and 1 sulfur. This would be the chemical formula for calcium sulfide. Thank you so much for watching this video. Remember to subscribe if you're new. And please let me know in the comments if you found this video helpful or if you have a different way that you solve these types of questions.